So think of Ethereum as this massive digital superhighway. It's where everything happens, from finance to art. But just like any popular highway, it gets jammed. To fix this, developers built an express lane, a sidechain. It's incredibly fast, cheap, it's powerful, but it comes with a hidden toll that isn't about money. So what is that hidden toll? What does it really cost? That's what we're going to dig into.
Okay, get this. This is the base speed limit on Ethereum's main highway, just 15 transactions per second. That's it. During peak times, like that whole NFT boom, this creates a massive, massive traffic jam.
And then there's this, up to 65,000 transactions per second. I mean, that's just a mind-boggling leap, right? The question is obvious. How on earth is that even possible? And, what's the catch?
So here's our game plan. First up, we're going to look at why Ethereum's main highway gets so clogged up. Then, we'll take a look at the express lane they built to fix it, the sidechain. After that, we hit the really crucial part, the catch, the security trade-off. From there, we'll see who's actually using these things today, the good and the bad, and finally, what this all means for the future.
All right, let's dive right in. Section 1, that great Ethereum traffic jam. Why does this digital superhighway get so clogged in the first place?
The rush hour analogy it's perfect. When everyone wants to jump on the network at the same time, and I mean everyone, for trading, for gaming, for minting NFTs, the demand just goes through the roof. And what happens? The whole network gets congested, transactions start crawling, and those tolls, what they call gas fees, can get just absolutely insane.
Now, here's the really interesting part. This isn't some accident or a design flaw. It was a deliberate choice. It's something called the blockchain trilemma. See, Ethereum's creators, they prioritize two things above all else, ironclad security and true decentralization. But there's an unavoidable trade-off. The price for that amazing security and decentralization was scalability. And that right there is the fundamental problem that sidechains were invented to solve.
So if the main highway is a total parking lot, how do you get around it? Well, you take the express lane, right? And that's exactly what a sidechain is. Okay, so what is a sidechain? At its core, it's its own separate, totally independent blockchain. It just runs in parallel to Ethereum. Think of it like a brand new, freshly paved service road right next to the main highway. The really critical piece, though, is how it's connected. There's this special two-way bridge that links it back to the mainnet. And because it's its own road, it gets to set its own rules, its own speed limits, it even has its own security guards. So how do you actually move your car or, your crypto assets from that clogged highway to the shiny new service road? It all happens through that two-way bridge. Here's how it works. First, you lock your assets up in a secure smart contract on the main Ethereum chain. Then, an exact replica, a sort of representative token, is minted for you over on the sidechain. Now you're free to use that replica token however you want on that super fast, super cheap sidechain. And when you're done, you just burn the replica. That sends a signal back to the smart contract on Ethereum to unlock your original asset. It's right back where you left it, safe and sound. And why would you do all this? Well, the benefits are huge. We're talking incredible transaction speed and throughput. The fees? Radically lower. Some networks like Scale even offer zero gas fees for users, which is a game changer. But it's not just about speed and cost. Sidechains are also like a sandbox for innovation. Developers can go wild, they can experiment with new, crazy ideas and features without ever putting the super secure, multi-billion-dollar Ethereum mainnet at risk. Okay, but this is where we find that hidden toll I mentioned. It's all about a security trade-off. Because that express lane, it has different security guards. Yeah, all that incredible speed, those low costs, that freedom to innovate, all of that independence, it comes at a price. And here's the absolute crux of it all. Sidechains provide their own security. They use their own set of guards, or validators, to approve everything. Now, this means if a sidechain gets hacked, Ethereum itself is totally safe, but everything on that sidechain is vulnerable. This is completely different from other solutions you might have heard of, like Layer 2s or rollups. They don't hire their own security. Instead, they borrow security directly from the ultra-secure Ethereum mainnet. This fundamental difference in security models, it creates all these other trade-offs. So for example, take a look at transaction finality here. Something called an optimistic rollup, which is a layer 2, might make you wait a whole week for your transaction to be fully 100% secured by Ethereum. A sidechain, on the other hand,
It's final as soon as its own internal rulebook, its consensus mechanism, says it is. So you get that speed, you get that autonomy, but it means you're putting your trust in a completely different and often smaller set of security guarantees.
Okay, so let's make this a little less abstract. Let's get concrete. Section 4, Real-World Power and Pitfalls. Where do these sidechains actually shine, and where do they stumble?
Oh, and the power is undeniable. I mean, look at this. Polygon is the engine behind huge mainstream projects like Reddit's digital avatars and even Starbucks' Odyssey loyalty program. And hey, if you've ever collected one of those Pope NFT badges at an event, guess what? You've used the Gnosis chain. And then you've got networks like Scale that are enabling entire ecosystems of Web3 games that would be literally impossible to build with high gas fees.
But here come the pitfalls. This is that hidden toll we talked about. That bridge, the thing connecting the sidechain back to Ethereum, is a massive, glowing target for hackers. A single bug in the code, someone manipulating a data feed, or even just stolen private keys, these things can lead to, and have led to, hundreds of millions of dollars in losses. That bridge, that link back to safety, is without a doubt the single biggest point of failure in the entire sidechain model.
So, with all this incredible power on one hand and this huge risk on the other, what's the future for sidechains? Well, it turns out they might be more like allies in a much bigger ecosystem, not just competitors fighting for the same turf.
You see, the future probably isn't about sidechains versus layer 2s. That's really the wrong way to look at it. It's better to think of them as different specialists working together. Ethereum is evolving into this really cool multi-layered ecosystem where we'll have different tools for different jobs. As one of our sources puts it so well, the future is going to embrace L2 heterogeneity. Now, that's a pretty technical way of saying we're going to have a diverse mix of solutions, all catering to a whole spectrum of needs. Some apps are going to need that ironclad Fort Knox level security of a rollup. But others, the ones built for speed, for customization, for experimentation, they're going to thrive on a sidechain. They'll remain these vital labs for innovation. And that leaves us with one final big question to think about. As Ethereum keeps growing and evolving, are sidechains going to be remembered as the crucial innovation labs that pushed the boundaries of what was possible? Or will they be seen as its most dangerous vulnerability? The answer is probably a bit of both. And that's the fascinating, high-stakes trade-off that's right at the heart of scaling Web3.